Hi, I'm Dominic, and this is our problem on momentum. So we'll start with the question. A 1,000 kilogram Prius moving at 25 meters per second south strikes another car, a Honda Fit 800 kilograms, moving at 30 meters per second south. Find the velocity of both cars after the completely inelastic collision. All of the momentum is conserved, and that's a big part. So with all the momentum is conserved, we can set up P1, P stands for momentum, initial, and then we equal it to P2, which is P final basically, so momentum final. So that's basically summed up by that statement. So we have our two cars right here. We have a Toyota Prius and we have a Honda Fit. And inelastic basically means that the total kinetic energy after the collision is less than the total kinetic energy before the collision. So it will be a lot easier to solve using momentum. So completely inelastic means that as the two objects collide, they'll stick together and then move as one after the collision. So for the free body diagram of the problem of momentum. So we're going to set it up first. We got M1, which we're going to call the Toyota Prius. So M1 equals 1,000 kilograms. And it also has a speed of V1. V1 will be 25 meters per second. And we'll call it positive because the coordinate axis will say, coordinate axis right here, we'll call the positive y direction down and the negative y up. So all our values will be positive for this problem. And then we have M2, which will be the Honda Fit. M2 equals 800 kilograms. And we have speed of V2, which will be 30 meters per second southbound, also positive because of the coordinate axes. Now after the collision, we'll get a combined mass because it's completely inelastic collision, so the masses will stick together. So we'll get M1 plus 2 and then V final, which we're going to solve for in the problem over here. So we can set up that M1, mass of the Toyota Prius, V1, the speed of the Toyota Prius, so equals M2, mass of the Honda Fit, and the velocity of the Honda Fit. So that's the initial momentum right there, that's P1. Equals P2, which is mass of both because they stick together. So it's M1 plus 2. Now we'll get you a value, and then V final of the objects once they stick together. That's what we're solving for. Right so there. We have M1 equals, we'll sub in the values right now, 1,000 kg. I'm sorry if I'm writing kind of small. 25 meters per second south. That's a positive value because our coordinate axes. Plus M2 is 800 kg. V2 will be 30 meters per second south. That's also a positive value. Equals, I'm going to squeeze this in here, sorry, erase that. M2 will be 800 kg, 1,000 Toyota Prius. So 1,000 kg plus 800 kg V final. That's what we're solving for again. So we got, I'm just going to exclude the units for this part. So we just got 25,000 plus 24,000 equals 1,800. We add those up. V final. So we add this side, we got 49K equals 1,800. V final. Divide out the 1,800. And the final answer, once we put the units back in, V final equals 27.22 meters per second. And that's our problem on momentum.